Okay, today for math class, I decided to go ahead and try to make a video for the items that we want to go through together. So hopefully you can push pause when you need to. You can rewind and watch something again if you didn't catch it, and you can kind of go at your own pace. Feel free as you're watching this, if you have questions, to stop it and call me over, and I can answer questions in between items. But I thought this way might help keep you a little more engaged, and you could move at the pace that you're needing to move at and can continue when you're ready to continue. So you should be on your lesson 13 packet that we started yesterday, and then we are going to go to exercise 3. Exercise 2, we finished the material about the red paint and the yellow paint to create the orange paint. So now let's look at exercise 3. First, of course, we want to read the whole problem to get our context. We have Jorge again, who now plans to mix red paint and blue paint to create purple paint. The color of purple he has decided to make combines red paint and blue paint in the ratio of 4:1. If George can only purchase paint in 1-gallon containers, construct a ratio table for all possible combinations for red and blue paint that will give Jorge no more than 25 gallons of purple paint. As I'm reading, I'm always trying to pull out the important information and determine what's important. So the second time I read, I go back and kind of highlight or pull out the information I need. So I know that I need to pay attention to the fact that we're combining red paint and blue paint in a ratio of 4:1. So red paint would be 4, blue would be 1. I also know that I need to do them in 1-gallon containers. I know that I need possible combinations, and I can't have any more than 25 gallons of purple paint. So I need to keep that in mind as I'm creating my equivalent ratios. As I look at the table, I pay close attention to the labels because, of course, that is super important to get the data in the right place. And I noticed they tried to trick me here with a ratio of 4:1. Red to blue, and then they set it up blue to red. So you always want to make sure you're paying attention to those pieces. So I would start my table by placing in the original ratio. So blue paint would be 1, red paint would be 4. Then I noticed they asked for a relationship. I can make a connection to our table up here where they asked us for the relationship in exercise 2 and kind of see what they want me to do for that part. So I know they're asking me what did I do to get 4. So 4, or my red paint is equal to 1, my blue amount, times 4. Then I would continue to put in equivalent ratios down the chart. If that's something you think you can do on your own, go ahead and push pause and fill it in, and then see if yours was correct next to mine. If you're not sure how to do that, then you can continue watching, and I will walk you through it. All right, if I know that I need 1 container of blue and 4 containers of red, that means if I had 2 containers of blue, I need 2 groups of 4 containers of red, which would be 8. I still want to keep in mind how many gallons I'm using because I don't want to go more than 25. So I see that this is 10. And if I wanted to, I could give a total column over here so that I could keep track to make sure I don't go over 25 gallons. Or you can just do it in your head. Then if I want 3 blue, that means I need 3 groups of 4 blue, or 4 red. So 3 groups of 4 red would be 12 red. So now I'm up to 15 gallons. Got to get close. If I had 4 blue gallons, I would need 4 groups of 4 red. So that means I would have 16. And 4 groups, remember, is just 4 times 4 to get me my 16. And 3 groups of 4 would be 12. Then I have, that would be 20 total. If I had 5 gallons of blue, that would require me to have 4 groups of 5, which would be 20 gallons of red. So I'm already thinking of my relationship as I'm doing this table and kind of paying attention to what I do from one side to get to the other. So to get my red amount, I took 2 times 4. And I did the same thing here, 3 times 4, and then 4 times 4, and then 5 times 4 to get my 20. All right, the next part of the problem says write an equation. That's a vocab word that I should automatically be picturing. An equation means that I should have an equal sign in my number sentence. So I need to write an equation that will let George calculate the amount of red paint. So if I'm going to calculate red paint, that means I need to figure out how I can equal red paint. He will need for any given amount. When they say any given amount or an unknown amount, that's when we use our variables. So that's when I would use a letter that would then substitute, and I could plug in any number that I wanted into that letter. So it says I will need any given amount of blue paint. So I'm going to make that be a B for my variable to stand for blue paint. So they want me to calculate how I get red paint. So how do I get to my red column over here? Well, that's where I would say, all right, what am I doing to my blue paint to get to red? In this case, I see that I am multiplying it by 4 each time. So that means if I take my whatever number I need for blue paint, times it by 4, I would then calculate my red paint amount. And I could test this and plug it in for each one. If B equaled 4, 4 times 4 would be 16, which is what I have here. And if B equaled 2, then I could do 2 times 4 equals 8, which would be my red here. So that equation does work. Hopefully you understand about variables. This just automatically makes this algebra. This is set up again so anybody at Sherwin-Williams or any paint store could plug in any number they wanted here to then figure out how many they needed for the red. Our next part says write an equation. So again, equals, and whenever I circle something or write something on my paper, it would be smart of you to go ahead and do it on yours as well so that you can kind of pull out that important fact and learn from my thinking. So if we need to write an equation that will let George calculate the amount of blue paint, so now we want to get out or equal blue paint he will need for any given amount. That's my hint that they want a variable of red paint. So since it's red, the variable, you want it to make sense so that you understand what you're working with. Any given amount of red paint, let's just use R. So now I need to think about how can I get out my blue paint if I'm putting in any amount of red. So let's look back at the table and see if we can see a relationship of what I'm doing to these numbers to get out these numbers. Hopefully you're seeing that these numbers are getting smaller when I get them out, and you're thinking about this. We could use this ratio of red to blue, 4 to 1, and think about how that comes into play here. So what I notice is that 4, if I put in 4 and want to get out 1, that would be taking 4 and dividing by 4. Or 8 dividing by 4 is 2. 12 divided by 4 is 3. So I notice that I am taking my red paint and dividing it by 4 to equal my, blue paint. Another cool connection here is if we had our red paint here, for instance, if we had red and we had 4 gallons of red, like our first line in our table, and I'm demonstrating it here, the blue would be 1/4 of this amount. So 1/4 of the group of red, which could be written like this: 1/4 red equals blue. So we will find this connection that timesing by 1/4 or finding 1/4 of the red group is the same as taking red and dividing it into 4 pieces. Because notice that's exactly what I did, is I took my red amount, divided it into 4 pieces. and then I took how many was in one of them. So I took 1/4 of the group of red. I know that gets tricky, and you can write it any way you want, but we just need to be able to make that connection that these are the same amount. And anything I put in for a red, such as 16, if I take 16 divided by 4, I would get out 4 groups of blue. Or here, if I had 16 reds, that means I would have 4 in each section, because I had 16, and then I break it into 4 equal pieces. That means 4 in each section, and then if I just wanted one of them, that would also equal 4. So either way I do it, 16 divided by 4 equals 4, or 1/4 of the group of 16 would also equal 4. So just depending on how you visualize that. Sorry, trying to get it big enough for you to see, and I think I'm cutting off parts. So let's look at this next one. If George has 24 gallons of red paint, how much blue paint will he have to use to create the desired color of purple? So this is where we do our substitution, and since we want to know how much blue paint, we can plug in 24 into this red equation here, and we can either do 24 divided by 4, which equals 6 to tell us the amount of blue, or we could take 1/4 of the group of 24. That's 1/4 the group of. And again, just to kind of demonstrate that, if this was 24 and I cut it into 4 equal pieces, I would need 6 in each piece. So if I take 1 out of the 4 pieces of that group, it would equal 6 as well. So I would need 6 gallons of blue paint. And I used this equation up here to be able to plug in the amount that they gave me. Now they say if George has 24 gallons of blue paint, how much red paint will he have to use to create the desired color of purple? So now I need to plug in for blue, which is our original equation from this page. So now I'm going to plug in to 4, or to here. So B times 4 equals R. So B times 4 equals my red amount. So if B, come on, focus. There we go. If B equals 24, I substitute. 24 times 4 would then equal, and I do that off to the side here, 4 times 4 is 16, 4 times 2 is 8, plus 1 is 9. So that tells me I need 96 gallons of red. And of course, I'm going to be going beyond just the math of it. I am also going to be thinking about these numbers. Does it make sense that if I had 24 gallons of red, that I would only need 6 gallons of blue? If I look back at my pattern here, well, yes, my blue needs to be a lot less than my red, and it goes right along with it. That's 6 gallons and 24. So yes, that does make sense. If I'm looking at 24 gallons of blue, again, that would go in this table here. 24 and 96 over here, that fits that I would have 90 or a lot more red than I have blue. It also fits into the relationship that it is 4 times as big as that blue number. So beyond just doing the math, I'm also plugging it back in and thinking, does that make sense? Now I would like for you to try this section B part, using reading it through and trying to come up with these equations here, similar to what I did for step A. When you finish that, I only have 30 seconds left, so I want you to make sure you write an equation. The total equals, remember, value of the ratio is the fraction in lowest terms, and then think about how it plays into your equation. When you finish with this, go to video 2.